So hello everybody. Here on the board I have sketched certain bones of a skull, and as I have said in my previous session, that I'm going to talk about the different views of a skull, like the Normas. So we will start from Norma Verticalis, the bones which are visible on Norma Verticalis, and the joints, as the specialized joints which are present only in the skull, and they are known as the sutures because they are the fibrous immobile joints. So like each bone which is making the Norma Verticalis is a flat bone, right? The two parietals, these green ones, and the frontal. So you can see that they are the flat plates with serrated edges, right? So these serrations, they fit into each other, right? And that's why the joint becomes immobile later on. But at the time of birth, these these bones, they are not completely formed. They are smaller in size, and underneath these bones, within the cranial cavity, the brain is also developing. It will be increasing in size and thickness. So that's why these sutures, these sutural joints, are slightly apart from each other. And especially like which structure is joining the sutures. So if you like imagine this red thing is, which I'm sketching through red color, are the fibers. These are the fibers. They are the collagen fibers which are joining the bones. So they are, connecting the two serrated edges of different bones. So they also allow the growth, the future growth of the bones, these flat bones of the cranium. Okay, so come back to our Norma Verticalis. So we are able to see the major part of the frontal bone from the top, the entire two plates of the parietal bones, and then there is a suture which is known as the coronal suture because it is running from one ear lobe to the other ear lobe, and it is you can also call it the vertex point of the skull, the topmost point of the skull. And why it is known as coronal suture? Because it is the region where crowns can be placed. Coronal suture. Okay, suture is a specialized type of joint which is the two serrated ends of the bones are joined to each other with the help of fibrous tissue, and later on this fibrous tissue becomes so small and tight that it literally fixes the joint, and they become immobile, right? But at the time of birth, okay, forget about it. First, we'll talk about the suture. So we will be able to see the coronal suture and another suture which is running from anterior. So the coronal suture is running from right to left or sideways. It's like transversely bisecting the skull. While a suture which is running from anterior to posterior is known as the sagittal suture or the mid-sagittal suture. That suture is present between the two parietal bones, so we can also call it the interparietal suture. While the coronal suture is between the frontal bone and the two parietals, so we can also call it frontoparietal suture. Okay? Then I have encircled this point where you can easily look at this region, that this is the point where the sagittal suture is joining the coronal suture. This point is known as brachma. Okay? Brachma. This brachma is the region where the sagittal suture is joining the coronal suture, and in a newborn baby, in an infant, because I told you that the bones are still developing when the baby is born because of the future expansion of the cranial vault due to the expansion of the brain. So this is a special kind of movement, like arrangement. And then the other reason why these sutures are loosely attached to each other, or these bones are loosely attached to each other, because at the time of birth, these sutures, they definitely will be overlapping. So the bones will be overlapping each other. So the frontal will be overlapping, the two parietals will be overlapping each other, the occipital bone will overlap, so that the size of the fetal cranium, or the newborn's cranium, will get smaller at the time of parturition. So it can pass through the birth canal with a little bit ease, right? So these are the main reasons why we have open sutures at the time of birth. So what I meant to say, that this brachma, which is visible in adult skull as like a completely fused region, it is open, and that region is known as, like, it has a diamond shaped opening. So this opening, where the two parietal bones and the frontal bone also develops in the form of two plates within the embryonic life. So right and left frontal bones, when we are born, the frontal bone is almost fused, except for its top part, which is closer to the sagittal suture, that stays like still divided, right? The fusion of the two right and left plates of frontal bone hasn't been completed at the time of birth. So that's why a baby is born with this roughly diamond shape or rhomboid shape opening, which is like, this is a soft region where you can feel the softness. There is no bone, just the scalp and the internal membranes of the brain are palpable, and that's why it is known as fontanelle, because it's a soft spot, as if you're palpating over water. Okay, so this is known as the anterior fontanelle. Okay, so anterior fontanelle is located at the brachma. It is the vertex of the skull, and it stays open. It allows the growth of the parietals and the frontal bone, as the brain inside the cranium is also growing. So the anterior fontanelle usually closes down at the age of 18 to 24 months, right? Then we have the two interparietal sutures, the interparietal suture or the sagittal suture. These are the structures which are visible when we view the skull from the top. So the Norma verticalis has two sutures, coronal and the sagittal, and three bones, the top part of the frontal bone and the two parietal bones. Okay? Then the next Norma is the view which is from the back. So when you look at the skull from behind, which bone is dominating? The back part of the skull, because this region is also known as the occiput due to this bone. This is the occipital bone. It's like, again, you can see it's sort of triangular plate of bone, and it is making joint with the two parietal bones lying in front of it. So if you imagine that you fit it in, right, this piece. So this is the occipital bone with all its external features, which I have tried to sketch, and it fits into the back of the two parietal bones. So this fusion or this region is known as, just like the region where the sagittal suture was joining the coronal suture was known as the brachma, this point where the occipital bone joins the two parietal bones and the sagittal suture is known as the lambda. Lambda, because of the shape of lambda. Okay, it's the inverted Y shape. Now let's talk about the Norma occipitalis, the view at the back of the skull, right? So this region is, in layman's terms also, we call it the occiput, right? So the reason why we call it the occiput or the back of the skull is because of this bone. This bone is known as the occipital bone. As you can see, it is like roughly, it's flat, but it's like triangular type, like a shaped bone, right? So here you can see as if like you take this piece and fit it in at the back of the two parietal bones. Okay, that's why they're making the very back portion of our skull, right? So these sutures, which are the joints which are between the parietal and the occipital. So they are known as, these sutures are two, like they are as if they are the two short limbs of a letter Y. So we call them the occipito-parietal or parieto-occipital sutures. And you remember this suture is known as the sagittal suture. So the point where the sagittal suture is joining the parieto-occipital sutures is known as the lambda. Just like this point where the coronal suture was joining the sagittal suture was known as brachma. So this point at the back of the skull is known as lambda because of its inverted Y shape, which is lambda. That is like it's a term, it's a symbol used in physics to measure the speed of light. Okay, so it's a Greek word. Because of the shape of this suture, they have named it lambdoid suture, or you can also call it the parieto-occipital suture. Okay, now the point, the lambda, just like brachma, at the time of birth, is just having very expanded fibrous tissue, because the occipital bone will be growing in size, so will be the parietal bone. So the suture, the lambdoid suture, is open, but this opening is not diamond shaped. It is like roughly triangular shaped opening, and it's much smaller. The opening at the lambdoid suture or at the lambda is much smaller than the opening at the brachma. That was the anterior fontanelle. So this is the posterior fontanelle. Okay, posterior fontanelle, the small fountain, fontanelle. Okay, because when you palpate the infant's skull, infant's cranium from the top, it gives a watery cushion feeling. That's why they are known as fontanelles. Okay, little fountains. And the reason why a newborn's skull is having multiple fontanelles, the two major ones I just have discussed, the anterior and the posterior fontanelle, because they stay open for much longer time as compared to the other smaller fontanelles. The reason is the one I just have given, because these sutures allow the overlapping of these flat bones, one on top of the other, at the time of parturition, at the time of birth, so that the cranium can pass through the birth canal with less difficulty. And then once the baby is born, the bones go back to their normal position, and these sutures, they allow the growth of the lateral, the frontal, anterior, posterior growth of the cranium with the proportion of the facial skeleton, because inside the cranium we have the brain tissue, which is also growing. Okay, so yeah, so I hope that you have understood the significance and the clinical significance of these fontanelles, a very important feature when we talk about the pediatric medicine, right? So the anterior and the posterior fontanelle closes down at the age of roughly 6 to 8 months. Okay, but the anterior fontanelle stays open up to almost 2 years of age, like 18 to 20 months. So an infant with a sunken fontanelle, if you are examining it, it is one of the examining steps of an infant when you are examining him or her for his state of hydration. You feel the fontanelle at the top of the skull, at the vertex, at the brachma. If the fontanelle is sunken, that means that the baby is dehydrated. If the fontanelle is full, or sometimes it is slightly bulged, that means the baby has high intracranial pressure. Okay, so that's a signal, that's a warning signal. And so is the sunken fontanelle, that the baby's body is deficient in water and electrolytes. That's why the fontanelle is dropped, like it's been sunken. Okay, so these are the two main clinical relevance related to these sutures. Now, one more thing. The Norma occipitalis, you can see on the occipital bone, I have sketched something, a central bump. That is known, this bump is known as external occipital, because it is a bump, so we call it protuberance. It's like a tubercle, external occipital protuberance. There is an internal occipital protuberance, which we will be looking at when we're exploring the cranial cavity. At the moment, we are examining the outside of the cranium. So the external occipital protuberance is a landmark for a few things. First, there is the confluence of dural venous sinuses lying just behind the external occipital protuberance. And the other external feature will be it provides the attachment, or it is the attachment site of the nuchal ligament, which is nuca. Nuke is a Latin word. It means neck. So the posterior nuchal ligament, or the nuchal ligament, is attaching. It's like a vertical band of ligamentous tissue that gives attachment onto the external occipital protuberance. Okay, that is the external feature. Internally, the confluence of sinuses, dural venous sinuses, is lying just behind the external occipital protuberance. Now, other than that, you can also see there are three nuchal lines, or the occipital lines, but I just have a sketch two. So there is a highest nuchal line, then there is a superior nuchal line, and then an inferior nuchal line. The inferior nuchal line is it is a landmark to mention that just behind the inferior nuchal line, right and left nuchal lines, are lying the transverse dural sinuses. So when we will discuss the dural venous sinuses, at that time, I'm going to show you how the inferior nuchal line are related to the right and left transverse sinuses. Okay, this is the significance of inferior nuchal line. Now, the superior nuchal line, it provides attachment to the trapezius muscle. Okay, so the muscles which are at the back of the neck. Okay, these lines, they are the ridges, elevations that have been created on the bone, on the external surface of any bone, because of the pulling action of muscles and ligaments. Okay, just remember this fact, that all these bumps and ridges have been created later on in our life. They are usually not present at the time of birth, because a newborn baby doesn't have much of muscular movement. As it starts holding its neck and starts turning around the neck, the sternocleidomastoid, the trapezius, and the other back and lateral neck muscles are going to pull at the cranium. The flat bones of the cranium will develop these ridges and protuberances. Okay. Other than that, I have used a different color code, the orange color. So that means the occipital bone is being colored as yellow. So these two bumps which are on the sides of the occipital bone, and I want all of you right now who are listening to palpate these bumps at the back of your ears. Okay, so these are the mastoid processes. They are the bumps originating from the temporal bone and lying just behind the ears. So the two mastoid processes are also visible when you are viewing the skull from behind. Okay? All right, now let's move on to a very extensive norma that is known as norma lateralis.